You know, I would think if I'm a student coming into the online program and I'm thinking I have to go and take a laboratory experience online, I might be a little concerned about that. Can I really have a hands-on laboratory experience from my home? That's what we're up against. That's what we need to accomplish.
As a department and a university, be able to offer the entire mechanical engineering degree remotely.
To take the entire mechanical engineering curriculum and convert it to an online equivalent.
MEE 491 is experimental methods class for senior level mechanical engineers.
And so we needed some sort of a balance between having hands-on experience, which absolutely is essential in the course, with the actual experience of collecting data, analyzing it, conducting experimental uncertainty analysis, and write professional quality reports. We used to have these big pieces of equipment where that was the only way to think about experimentation. Nowadays, sensors are microsized. Your cell phone has as many sensors and more than you're going to analyze in this class, it turns out.
So what we've done here is we've basically created a series of laboratories, one of which is actually a physical lab with electrical components.
In the laboratory environment, there's a pressure transducer there. I can't touch it. We're going to send you a pressure transducer you can touch. You're going to be conducting literally hands-on experiments with thermocouples, pressure transducers, flow meters in your house, taking real measurements. The data is random. You're going to have real uncertainty in that data that you're actually collecting from it.
For a pressure measurement, 100 kPa. It's 100 kPa and it bounces around just like a real instrument would.
Once we understand all that, let's look at systems. Much more complicated, but the measurements are the same.
The HVAC lab had this really nice setup. So it's this very elaborate machine. We cannot send that to every student that's taking this course remotely. So what we have done instead is we basically created all these simulations, set up the ability for the students to manipulate that input heating, which is exactly what they do in the real lab. We have created this GUI that allows the students to click on the device as a whole, look at the temperature and the pressure readings at certain locations in the system, exactly like they do in the real lab.
I think the biggest thing is that it really gives like a sense of autonomy over the labs for each individual. Like an in-person experience, it's more just like watching it happen in big groups. You don't really get the opportunity to kind of like mess with it yourself and try different things with it.
Because in the in-person experience, you have 4 or 5 students to a group trying to collect all this data in a 3-hour window. So in this setting, although they don't get the experience of actually interacting with a real HVAC system, they do get to actually collect the data by themselves. So now every single student actually has the opportunity to collect and process data.
It's cool that we're at the point where we can use computer softwares and stuff like that to model the real world in a way that students can interact with, almost as if they're in person.
That's more or less what we've done, and it's important because as higher education grows across the board, it's going to be difficult to have all those students on ground in a laboratory space making these measurements. So we need to try and figure out creative and innovative ways to give them similar experiences that hit on the key aspect, which will be challenging for students, I'm sure, but also it'll, at the end of the day, I think, benefit them even more.